Okay, in this video we are going to look at different examples of different application problems that a lot of students tend to come across, especially when dealing with the beginnings of pre-calculus content. Now, the biggest thing about all of these applications is your ability to be able to draw the actual picture of what you are talking about, because that is going to be the best way for you to be able to answer the question you are being asked. So the first thing that we need to look at is we need to look at a little thing called the angle of elevation, or your angle of depression. This is going to help you figure out what your triangle looks like when you are working on some of these application problems. So I've kind of drawn this mini picture here of what I would consider to be a terrifying scenario between, say, with my 6-year-old son. So let's say that this, little stick figure down here, well, that's me down on the ground, and I have noticed that my 6-year-old son has climbed the big giant maple tree in the front of my house. So here's my big giant tree, and there's my baby up in the top. Well, when I'm just standing there and I look straight at the tree, this is called line of sight. Okay, so it's important to always establish what actually is your line of sight. So your line of sight essentially is going from your eyes directly straight to whatever the object is you are looking at. So for me, the line of sight would be looking straight at the tree in whatever spot lines up with that line of sight. Now, the moment you start, say, tilting your head up to look either up or tilting your head down to look down, you're changing your elevation, because you are changing that line of sight. It's no longer standard or straight. So in this case, for me to look up at my son who's in the top of the tree, I am raising my head up, so you can think of it as it is a positive motion. And so in this case, my line of sight is moving in an upward direction, and we call this elevation. So in this problem, if I wanted to know the angle of elevation, I would be looking at my angle. In other words, what was the angle difference from looking at my line of sight up to looking at my son? How far up did I have to go? Well, the same would hold true, say, for my son in the top of the tree. So he climbed up there, obviously, to look at something, and so he would have a direct line of sight. So again, we have his line of sight, which would go straight from his eyes, straight out, horizontally, and he'd be looking at whatever he was looking at. Now, when I start screaming like a crazy person, obviously, he's going to look down at me. And so here, in this case, he is looking down. So we consider that as like a negative motion. You're looking down. And so we would call this depression. Now, the reason these two concepts are so important is because you need to be able to draw the triangles for the different problems you have, and knowing what the word depression or elevation means is really going to help in terms of being able to draw that triangle, which is going to allow you to solve your problem. So let's take a look at some examples so you can see exactly what I'm talking about here. So in this first example, we have that a mahi-mahi is hooked on a 70 feet a fishing line, and it's 10 feet of which is above the surface of the water. The angle of depression from the water surface to the line is 40 degrees. How deep is the fish? So the first thing that you need to do is you need to draw your picture. And now you don't have to be a perfect artist. This is all I would do. First thing, I know that I've got a water line, so I would input my water line, which means I've got to have a boat sitting on top of the water. So there's my boat. And then with that, what do I know? Well, I know from the boat, I'm going to have a line of sight. So I would input that as a dashed line. And then I also know that I've got an angle of depression of 40 degrees. So here I would go ahead and I would kind of draw my angle of depression. Now you can freehand it, or you can be want to be more exact and say use a ruler. Of course, most people don't require, but for all intents and purposes, we'll go ahead and do that. Now, there's a few things that we know. Okay, first, we know that I have this triangle now here that I can go ahead and input. And I can also look at the information that I was given. So we were told that we had an angle of depression, so we're going to come down in this downward direction, and we're doing that at 40 degrees. Now, the other thing that we've been told is that we have 70 feet of fishing line, and we were told 10 feet is above the water. That being said, that means 60 feet has to be below the water. So therefore, when we're looking at it, we know that we've got at least 60 feet down here below the water. Okay, so this could be 60. And we want to know how deep the fish is. Okay, so we want to know X. So X is going to be from the water line down to however deep the fish is. And let's say this is our cute little fish down here. Okay, nothing. There we go, our little fish. So we need to know what this value is, this X. Okay, now the reason I'm using 60 and not the whole 70 feet is because I'm not looking at the distance from my line of sight. I'm looking at the distance from the water. And this is why drawing these pictures are so important. This extra 10 feet above does not matter. So if we look at it, the triangle that's important for us is going to be this one, where we've got our water line, we've got our distance, height, and then this would be our fishing line. We know our angle is going to sit right here. This is the unknown, and this is 60. And so that's what we have to solve. So if we look at it, we have opposite over hypotenuse. So in this problem, we are going to use that the sine of 40 is going to be x over my 60. To solve for x says I multiply both sides, so we get that x is going to be 60 times the sine of 40. And then you just simply use your calculator. So again here, to demonstrate using, say, the graphing calculator, we would do 60 times sine of 40, close it, and hit enter. And here, what this is going to tell us is this tells us that x is going to be 38.57 feet. Okay. All right, let's look at another one. All right, so here we have that a weather balloon is directly west of two observing stations that are 10 miles apart. The angles of elevation of the balloon from the two stations are 17.6 degrees and 78.2 degrees. How high is the balloon? Okay. So again, the first thing we want to do is kind of draw a picture. So what do we know? Well, we know that we have this weather balloon. Okay, so we'll go ahead. We've got our little balloon. And then we've got some information here. So we are told that the balloon is going to be directly west. So we're going to go ahead and draw our elevation angles. So we've got, say, one coming here. And so this right here, we could consider this to kind of be like your land. So I would kind of somewhat dot it just so you can see what you're doing. And then we've got the other one would maybe be coming, say, like way out over here. So let's go ahead and draw that one down. Alright, so with this, we know that we have our first observing station. Okay, so we've got that first little station. And then we have our second, so that's kind of what we're doing here. And we are told that the elevation of the two stations are going to be 17.6 degrees and 78.2 degrees. So we need to know which station we're putting at what angle. Well, the further away you get from something, the less your elevation has to be. So in this case, we're going to have, say, alpha, and then we're going to have beta. And what we know is that this one is going to be 17.6 degrees, whereas my other one is going to be 78.2 degrees. Why? Because the closer you are to an object, the further you have to look up at that object. Now the other thing that we need is the reference for, say, our right triangle here. And so we know that we need to drop our straight line down from our balloon in order to form the right triangle idea. Now the reason for that is because we want to know how high the balloon is. So this is the value that we are actually looking for. Okay? So now we need to figure out how we're going to put all of this together. Well, what also do we know? We know that these two stations, so from here over to here, is going to be 10 miles apart. What we don't know is this piece. We don't know how far this first station is. So we could call that Y. So if you look, we have two triangles here. So the first triangle that we have, we'll do here in red. So if we take a look at it, we've got our 90. This is our X. This first part would be Y. And then we have angle beta down here, which we know is going to be 78.2 degrees. Okay. Now that being said, we very quickly could figure out the other angle, but we don't necessarily have to have it. Now the other thing that we have is we have our other triangle. So the other triangle here, make that slightly longer. Again, this is X, but this bottom side is going to end up being Y plus 10. We called this angle alpha, which we know to be 17.6 degrees. Okay, so that is everything we know. So we need to start putting some things together here. So first and foremost, I have a degree, but I have two missing sides. And the two missing sides here that I care about are opposite over adjacent. So what I'm going to do is I am going to put together that I know I have the tangent of 78.2 degrees is going to give me X over Y. It's the first thing that I know. Looking at the other triangle, I also have tangent of opposite over adjacent. And so in this case, I also have that the tangent this time of 17.6 degrees is going to give me x over y plus 10. Okay. Now if I look at these two equations, notice both of them have the same variables, x and y, x and y. So I could solve both of these for an identical variable. And in this case, I'm going to solve for x. So in this first one, I end up getting that x is equal to y tangent of 78.2. And on the other side, I end up getting that x is equal to y plus 10 tangent of 17.6 degrees. Now in doing that, notice I'm telling you that x has two different equations to work with. So this means I can set these two equations together. And what I hope you're starting to see is that by setting them together, we can solve for the y value. So here, we now are going to use that y tangent of 78.2 is equal to y plus 10 tangent of 17.6. And in this case, we have to solve for y. So the first thing we need to do is distribute that tangent through. So here we're going to get y tangent of 78.2 is equal to my y tangent of 17.6 plus 10 tangent of 17.6. I'm going to move my y term over. So if you notice, we're pulling on some of these basic algebra concepts. So we're going to move that y over. So we have y tangent of 78.2 minus y tangent of the 17.6 is equal to 10 tangent of 17.6. You can pull that y out. So we pull out the y, and we're left with the tangent of 78.2 minus the tangent of 17.6 equals 10 tangent of 17.6. Now, obviously, to get y by itself says that we have to divide, so this becomes 10 tangent of 17.6 divided by the tangent of 78.2 minus the tangent of 17.6. Okay. Now here's where we would use our calculator. So let me scoot this over here. And so we've got our calculator. And so here what we want to do is we want to go ahead and plug our values in. So the values that we're working with is, first we're going to open up parentheses, and we're going to do 10 times the tangent of 17.6 and close off the top. We're going to divide that, and we're going to open a new parentheses. Here we're going to do the tangent of 78.2, close it, and we're going to subtract the tangent of 17.6. Then we're going to close it, close off the bottom, and hit enter. And here we come out with y being 0.7097. Okay. So when we're looking at this, that's what we end up for y. Well, we still have to be able to find x. So in order to do that, now if you remember, we had this initial triangle and we were trying to solve for y. And so y we found out is going to be 0.7097. So we're going to put that in. That y here is 0.7097, which means I can actually solve for my x value. Why? Because I knew the tangent of x over y is what I had to search for. I had to solve for x. So in this case, what do I know? I know that x is equal to that 0.7097 tangent of 78.2. So in this case, I would go ahead and I would take my answer. So I would go times, so I get my answer that was in my calculator, and I'm going to multiply that by the tangent of 78.2. And then I'm going to go ahead and hit enter, and we come out with x being 3.40 miles. And so this is what we were looking for. We were looking for how high the balloon is off of the ground, and we come out with 3.40 miles. All right, let's look at another one here. All right, so in this one, we have the ramp of a moving truck touches the ground 12 feet away from the end of the truck. If the ramp makes an angle of 30 degrees relative to the ground, what is the length of the ramp? So in this case, what do we know? Well, we know we have this truck here. So I would go ahead and just draw myself kind of a rectangle, which is my truck. If you want to go ahead and say put your little wheels on, you can, but I mean, like I said, it doesn't have to be anything fancy. Now, the one thing that we do know is we know that trucks are going to rest on the ground. So I would go ahead and I would input your ground there, just so that you have it. Now the other thing that we know is we know that we have this ramp. So the ramp is going to come out of part way through the truck, and it's going to come down and meet the ground. Okay, so that's what we've got here. And so if we look at it, one of the things that we were told is we were told that the ramp is going to make an angle of 30 degrees relative to the ground. Well, relative to the ground is right here. Okay, where we are talking about using the ground and using this as my angle. And so here this would be 30 degrees. So the question wants to know is the length of the ramp. So we want to know this piece here. What is this? The length of the ramp. Well, there was one other piece of information we were told. We were told that the ramp touches the ground 12 feet away from the end of the truck. So we know that this part of my triangle right here has to be 12 feet. So there's your picture. So if we look at our triangle would look like this, where we would have our angle. Here's your 90. This is the missing part. This is 12, and down here was 30 degrees. So here, if we look at it, I have adjacent over hypotenuse. So for this one, what I'm actually doing is I'm going to do the cosine of my angle is going to be adjacent over hypotenuse. And I just simply need to solve for x. So to do that says I have to multiply. So my x is going to end up being 12 over the cosine of 30 degrees. And then I can pull out my calculator and do just that. Okay, so here what you're going to end up with is the fact that x is going to be 13.86 feet. So my ramp is 13.86 feet. All right, let's look at another one here. So this one is going to be more about construction. So here we need to know what the pitch is. So the pitch of a roof is going to be your slope. And then you're going to use the idea of your pitch to find the angle between the width of the home and the rafter. Okay, so those are the two concepts that we need to keep in mind. The question says that Blaze, an architect for luxury homes, is designing a house that is 46 feet wide with a roof whose pitch is 11/12. Determine the length of the rafters needed for this house. Round the answer to the nearest tenth of a foot. So we need nearest tenth, so we need to keep that in mind. Now let's go ahead and draw our picture. Okay, so what do we know? Well, we know we've got this house, so we're going to go ahead and add in this little picture, and then the other thing that we know is we've got this roof. Okay, so your roof would kind of come down, say maybe something like this. There we go. Exciting. Now there's a few things that we know. First, you could drop in your dotted line here, which is going to give you part of a triangle. Now the other thing, what we don't know, is we want to know the length of the rafters needed for the house. So we're kind of looking for, say, this value. Now here's the other thing that we do know. We know that the distance here of that house was 46 feet. Which means if we cut it in half, my distance here is only going to be 23 feet. Now why is that important? Well, it's important because we have to look at this triangle two ways. Okay? First, we have to look at it in terms of pitch. So we're going to go ahead and we are going to take this triangle here that you see, this one, and we are going to blow it up. So we're going to use this in terms of pitch. The triangle we're looking at would be the triangle that's inside, or that's going on with your roof. So we know that this would be, say, your angle. We were also told that that pitch is 11/12. We know that pitch is given as slope, and if you remember, slope is going to be change in y over your change in x. So when we give you a pitch of 11/12, we're telling you that your change in y is 11, your change in x is 12. Now what we don't know is we don't know this piece here. Okay? So when we look at it, we have opposite over adjacent. So we've got that the tangent of my angle has to be 11/12. Therefore, we know my angle is going to be the inverse tangent, or tangent to the -1, of 11/12. So you can use your calculator in order to calculate just that. So if we bring our calculator out, we've got our tangent button here. So we're going to go second tangent, brings in the inverse tangent, and then we're doing 11/12 and hit enter. So here we're told that our angle is going to be 42.5. So here we find that the angle of our roof has to be 42.5 degrees. Now that's not actually the answer, because we want to know the length of the rafters. So we're trying to determine your rafters. All we've determined is the angle. So this is where we need to go back and we need to kind of look at the bigger picture of what we're doing, which means in this case we have a new triangle. And so here my triangle would be something like this, where I have it up, it comes down, and in this case this is going to be my theta. I know this is going to be 23, and that is what I'm looking for. So in this case, what I have here is I know that this is going to be 42.5. I have adjacent over hypotenuse, so I've got the cosine of my angle is going to be 23 over x. Well, I knew my angle is 42.5, so my x is going to be 23 divided by the cosine of 42.5. So again, using your calculator and input your values, you would come out with 31.2 feet. And this would be what we're looking for as the feet of the rafters. So sometimes you have to use two different triangles in order to get the result that you are looking for. Alright, now the last one that I want to look at is a bearing problem. Bearing problems are directional problems. It means you have to pay very close attention to the direction being said in terms of north and south. So here, what you need to know is if you see n degree measure W, what that means is you are 55 degrees west of north. Okay, so this has to do with a compass. Remember with your compasses kind of look like a quadrant where you have north, south, west, and east. So you need to keep your compass in mind when setting up these problems. Alright, so here we go. We have in extremely large forests, it is not cost effective to position forest rangers in towers or to use small aircraft to continually watch for fires. Since lightning is a frequent cause of fire, lightning detectors are now commonly used instead. These devices not only give a bearing on the location, but also measure the intensity of the lightning. A detector at point Q is situated 15 miles west of a central fire station at point R. The bearing from Q to where lightning hits due south of R is south 37.6 degrees east. How far is the hit from point R? So we need to kind of draw this picture. So first and foremost, we need to pick a place to start. So I would say that we need to start just right here in the beginning, where we're talking about a detector at point Q is situated 15 miles west from a central fire station. So first and foremost, we have a fire station. So right here would be our little fire station. We're going to go 15 miles west, and this right here is going to be our point Q. So when we're looking at it from our fire station to our point Q, this is kind of what we have. And so this would be 15 miles. Now, the other thing that we know is we know that the fire station was point R. So I would label that with an R. And then here it says the bearing from Q to where the lightning hits due south of R is that degree. So what we kind of need to know is we need to know where the fire is. So my fire is going to be basically down here. We're going to draw this straight line kind of down here. And we're going to go ahead and put in our fire. Alright, so we kind of got this little fire going on down here. Had a little fun. Now, what do we know about it? Well, we don't know what this is. However, we do have your distance from the fire to your station. So we kind of know that we've got this distance here, which is going to help us with our triangle. And the other thing that we know is we know an angle. So if we kind of draw straight down from our point Q here, we've got this angle where we are talking about the bearing from Q to where lightning hits due south of R. So due south of R is going to be south 37.6 degrees east. What that's talking about is that's talking about this angle right here. So this angle from here to here is going to be my 37.6 degrees. Now, if you remember our compass, north, south, west, and east. So here, that's exactly what we did. We are south, and we are 37.6 degrees east. So we come south, and then we swing over. So that's where that angle is coming from. So now we actually have everything we need, with the exception of this. You need to remember something from back in geometry class, which says that if you have two parallel lines cut by a diagonal, then the opposite interior angles are the same. This means that this angle right here is also 37.6 degrees. Who knew geometry would show up in pre-cal? So as long as you remember that idea, then you're going to have no problem. And if you look, we've got our triangle here. So we've got our angle, and we have opposite over adjacent. So in this case, we are going to do just that. The tangent of my angle is going to be 15 over x. Again, solve for x. X is going to be 15 divided by the tangent of my angle, which was 37.6 degrees. So in this case, you're going to use your calculator again, this time with tangent, and you're going to find out that x is 19.5 miles. And this was what we were looking for. So there you have it. A bunch of different story problems, word problems, all using triangles in different ways. And as you noticed, in each problem, we needed to draw the picture so that you could definitely see it clearly. So if you have any questions with any of these problems, please let me know. If you feel like you needed additional problems or additional help, please let me know that too. Otherwise, I hope you enjoyed and got a lot of information out of this video, and I will see you next time.